Hey guys, I just wanted to talk about, pardon me, the Module 5 DQ, just to make sure you guys were able to hear and hear me talk through just the solution. So the problem again, just to remind you, says Angela works at a job where she earns $225.50 when she works 8 hours, and when she works 17 hours, she earns $376.25. Assume the amount of money she makes increases at a constant rate with respect to the number of hours worked. So question number 1 says to identify the input and output quantities. I'm actually going to get it right here. So assume that the amount of money she makes increases at a constant rate with respect to the number of hours worked. So remember, it's always going to be output with respect to input. So my input here is going to be number of hours worked. It says to define a variable, so I'm going to call it T, like time. Output is going to be the amount of money she makes. Money made. Specifically, we're going to be measuring in the unit of dollars, and I'm going to call that A. Question 2 says, using the method demonstrated in Module 4, create a formula for a linear function that represents this situation. And really, it's Module 3 and Module 4. So what I'm going to do is I'm going to make a table. You guys know me by this point, and you know that I love me some tables. So I'm going to put that data into a table. And again, it doesn't matter which order you put it in. I generally put the smallest to the biggest for my input value. But then I need to find my change in input and my change in output. So 17 minus 8 should be 9. Let's see if I can not forget how to do math over the holiday break. Hopefully just like you guys. And then my change in output is going to be $150.75. So I need to find my CROC, so that's my change in output over change in input. So 150.75 over 9 is going to be $16.75 per hour is going to be the units. And so then I just need to pick one of my 2 points to be my reference point. I'll just pick the first one because it's there first. And so then I'm going to use my general form of a linear function like was presented in Module 3 and 4. And this is going to be my formula. Right here. For number 3, it says use the formula to determine the amount of money Angela made when she works 32 hours. So I'm just going to use that, and I'm going to input 32 in for the number of hours she worked. You could also, I know it says use the formula, you could also add it into a table if you are one of those people who likes to organize all that info in tables and kind of do what we did when we were filling in our tables before. But if you do it either way, you should get $627.50. Part 4 says to convert your formula you created to y equals mx plus b form. Really what I can do, probably the easiest way to do that, is to distribute and combine like terms. So let's do that. So I'm going to distribute the 1675 to both. So that means I'm going to multiply both of those terms by 1675. So let me multiply that by 8. Don't forget your negative sign there. So minus 134 plus 225.50. So then I have to do the negative 134 plus 225.50. And so then, oops, sorry guys. I'm going to get A equals 1675 T plus $91.50. So at her job, it sounds like she gets a base pay of $91.50. Don't know why. And then every additional hour she works, she makes $16.75. Not a bad deal. And then part 5 says assuming that Angela will work at most 40 hours, determine and list the practical domain and range of the function. So essentially what we have is we have a function. If I were to graph it, which you guys are getting into, I guess that was module 6. Essentially we're going to have some formula that looks like this. So this is T, this is the amount of money. So we know she's going to work at most 40 hours. So remember that domain is getting at potential inputs of my function. And so inputs are my horizontal axis. And so essentially the least amount of hours she can work is 0. And the most amount of hours she can work is 40. So essentially here, and by the way, this point right here is 0, 91.50, right? Which we can get from my y equals mx plus b form. And so up here, we know the most she can make, or the most she's going to work is 40 hours. And then we'll need to find out how much money she made here. So we'll come back to that in a second. But for my domain, so it's going to be 0 is less than or equal to t. Oh, my kids are saying hello to you.
Mama,
Oh, not right now.
there's a new busty one.
Oh, thank you.
There's a snowy one.
All right.
And then snow put on haggis.
Okay. All right, thanks. All right, sorry about that, guys. Welcome to my real life. So my domain is from 0 to 40 hours because that's the least amount of hours you can work up to the most. And then the range is going to be what's the least amount of money she can make up until the most amount of money, because that's my output, which is what range is. So the least amount of money is happening right here at $91.50. And then the most amount of money she can make is happening right here. So what we need to do is use our formula, and we need to figure out, okay, well, if she works 40 hours, it doesn't matter which formula, I could have used the other one too. So I could have done this one. May as well, since it's a more simplified version. So if I do those, either one, I'm going to get that A equals, oops, not that, 761.50. So $761.50 is going to be the most amount, because this is going to be 761.50. So that's the most amount of money she can make when she works 40 hours. So that's really kind of the process that you should do to answer questions 1 through 5. If you have any questions, let me know. Hopefully your process isn't interrupted like mine was, but again, welcome to the reality of life right now. I hope you guys have had a great holiday weekend, and like I said, let me know if